Welcome, everyone. This is the New England chapter of NEAAPOR webinar series. And today we're talking about election forecasting. And we are very, very fortunate to have with us G. Elliott Morris. So I'm going to do a brief introduction of Elliott, and then he's going to speak for about 20 minutes or so and show some slides and show some information about his model and sort of modeling in general. And then we're going to take questions from the audience. So you can use the Q&A function on your panel there to submit questions for Elliott, and I'll read through those and pose those to Elliott after he's done talking. But first, let me introduce Elliott Morris. He's a data journalist at The Economist. Actually, I should stop and introduce myself first. So I'm Brian Schaffner. I'm a professor at Tufts. I'm also now the Vice President of NEAAPOR, the New England chapter of the American Association of Public Opinion Researchers. I, of course, as someone who studies public opinion and polling, and sort of follows Elliott religiously on Twitter. So I'm very happy to have him here. And so Elliott's a data journalist at The Economist. He's responsible for many of The Economist's election forecasting models, including, of course, the 2020 US presidential election forecasts. Elliott received his undergraduate degrees in government and history from the University of Texas just a couple of years ago, actually, at the same time that he was gaining fame as the new kid on the block for election forecasting models. The Economist wisely hired him as soon as they could. He's also writing a book right now for Norton called No Margin for Error, and it's due out next year, and it'll focus on the history, influence, successes, failures, and the future of public opinion polling, which is something that we're all very interested in. And of course, many of you know that Elliott is prolific on Twitter, and not just in terms of debating modeling decisions with people whose first names are Nate, but also just in general for providing awesome and excellent insights about American politics and public opinion and data journalism. And so with that, I'll turn it over to Elliott, who's going to talk a little bit about forecasting the 2020 election.
Yeah, well, thanks, Brian. What a generous introduction, and thanks for plugging my book. The editor will be certainly happy. I'm going to talk about The Economist's election forecasting model. We're going to talk about what goes into the model as inputs and some of the innovations we've made with the model, especially given the audience, about how we're treating polling information differently than some of the other forecasters, some of whom, as Brian notes, names begin with Nate. I have some slides to share. Don't get too caught up in the visual display of information. I will be saying a lot that's not on the slides, if I can figure that out. And yeah, so there we go. So don't be caught off guard by the very red background. That's what The Economist has me do. Before I start, I want to say we partnered with a few other people in creating our polling aggregation and forecasting model. So by no means is this my sole work or just the work of people at The Economist. We worked with Andrew Gelman and Merlin Heidemans at Columbia University to implement a model that's fully Bayesian, runs in Markov J Monte Carlo on Stan, something that we're really proud of. But of course, while it's my baby, certainly I'm not the only one feeding it. Maybe that's the analogy that works. So here is last week's screenshot of The Economist's top line predictions for the election. Things are a little changed since the last time I made this slideshow, essentially. We're pretty confident in a Joe Biden victory. We don't think it is a sure thing. But here's a good way to orient yourself to what exactly we're predicting right now. A 91% chance that Joe Biden wins with a pretty hefty electoral college tally. Now, I will, like I said, I'll explain what goes into the model, and then we'll have a Q&A in about 20 minutes or so. So if you have questions in the meantime, you can put them in the chat or the Q&A or save them for later, and I guess Brian will pick up on some of them along the way. The starting point for our model is what we're calling the economic and political fundamentals of the national environment. These fundamentals give us a good idea of a range of expectations for how the election should play out nationally. And I'll explain what economic and political fundamentals we use. However, of course, the national popular vote, as we saw in 2016, is not the thing that predicts the presidency. So we also decompose this national prediction into state level predictions. And since we're using a Bayesian model, we're going to call these priors, although they're also predictions from a model, so they're not strictly prior information. So we start off with essentially 51 predictions for how the state level elections are going to turn out. And then we aggregate those predictions with polling information and simulate the outcome of the election. And those are basically the three large steps of how this works. That's how the presentation will proceed. So first, on our national fundamentals, we of course draw a lot on the political science literature, on the relationship between economic growth and presidential vote share, parameterized as the incumbent's share of the vote. So we've scaled 8 different indicators of economic growth, including things like the annual change in unemployment, which is right now rather negative, annual change in real disposable income, which for a while was positive, but is now trending downward at the end of pandemic unemployment insurance and extra state level unemployment insurance over the past couple of months. And then we scale our average of all the economic growths per these indicators to form what we think is a pretty comprehensive measure of how the economy grows. And we think this is an important iteration on the political science literature, which typically only uses 1 or 2 variables like GDP growth or disposable income that are prone, I guess, as we've seen this year, to large sort of 95% interval changes in the relationship between how the variable works and how it might predict election results. So we've tried to safeguard against some of that. Secondly, we use presidential approval in our model. We think that there's information about the political environment that is close to an economic or a sort of fundamental reading of how people are predisposed to vote that the economy doesn't pick up. So in the case of 2017 through 2020, that would be a sort of fundamentally unpopular president. And so using presidential approval helps us basically calibrate our expectations for the race based only on what the economy would tell us. In a departure or a further iteration, I might say, from other forecasters and the traditional political science literature, we're also interacting our measure of economic growth with political polarization to account for the dampening effects of economic voting over time. So we've seen a sort of growing and persistent disconnect between, say, consumer sentiment and approval ratings for presidents since Obama, and especially under Donald Trump. And our model knows that this relationship between the economy and presidential approval is changing because essentially, parties are locked into their presidential vote more than they would have been in, say, the 1970s. So we've parameterized polarization as the share of voters in the A and the S who say they've voted for a different party over the last 2 presidential elections. And that share of swing voters has declined from around 11 to 5% these days, or perhaps even lower in more polarized open elections. We also include the standard term for whether or not there's an incumbent on the ballot. Our research found that economic growth is more predictive of presidential voting when people are evaluating a president rather than if they're making a choice between 2 candidates in an open election. So here is a scatter plot we ran in the Economist back in June. So these numbers aren't necessarily current. This was 224 days before the election. We're 15 or 14 days out now. So they've changed around a little bit. The relationship has gotten a bit tighter. But note that the relationship between the economy and presidential vote is by no means perfect. We think it's a rough guide to expectations. And here we're just showing you a linear extrapolation of what we would have predicted only on the economy, which was a pretty resounding defeat for the president, one that would probably be too large. So here the relationship is obviously not accounting for polarization. We would think that the line would sort of slope a bit like an S curve or a sigmoid function. Presidential approval ratings, in contrast, are better able to predict election results, at least 224 days out, like I said. So here's another tight relationship. And in this case, the president's approval rating, while negative, is not entirely out of the range of expectations for a re-elected president, especially given the margin of error here. And then one final time here, I'm showing you the difference between predictions for an incumbent president and an open seat. So the blue trend line in these two graphs, the one on the right being our measure of economic growth, and the one on the left being net approval ratings, shows you a tighter relationship for incumbents on the ballot rather than open seats being the red flatter line. We want to combine all of this information, of course, in a way that's not overfit. I've noted here our formula has sort of one mess of an interaction and presidential approval. Like I said, we only really pay attention to economic growth when there's an incumbent running, and we want that term on the economy to change with polarization. So we use regularization to train our linear model to make sure that we've calibrated essentially the coefficient on the first term so that it's predictive of elections that it hasn't seen yet. And that prior fundamentals national model has a margin of error on the national Democratic margin of close to 10 percentage points, or slightly even larger at the state level, which we'll get to. So again, keep in mind, this is not a perfect one-to-one prediction. We do think it's more predictive, especially since we're using approval ratings, than some of the other leading forecasters think about fundamentals. Of course, our forecast this year has been steered pretty heavily by fundamentals, saying that Joe Biden had about a 5 percentage point lead nationally, or should have won by about 5 percentage points, versus some of the other models which had Trump winning based off of the economy alone, which of course might also be due to them using older economic than we do. We stop in 1948, while some of the other forecasters go back to 1888 or so. So we think it's a pretty good model, better than others, but again, by no means perfect. We think that this formulation is better able to explain the election than to predict it. But of course, we are still interested in predictions. Now, like I noted, the national election is not necessarily what we're interested in. We want to be able to predict the Electoral College, so we need state level information. So we trained a second model. This is really where we're going to start referring to our predictions as priors, because now they're at the state level. So we train a different model. Just imagine a different data set now to predict the Democratic share of the vote in each state using the previous partisan lean in that state, whether or not the incumbent or the presidential or vice presidential candidate is from that state, which we control with the size of the state. So we find that home state effects are larger in smaller states, and we predict the state level Democratic vote share conditional on the national vote share in that election. So we essentially have a model that allows us to predict any given state, so long as you apply an estimate of how far to the left or to the right that state should be in the election, and your national level prediction, which of course yields itself well to making predictions for 2020, especially if we already have our fundamentals level prediction. So for Florida, for example, we see that the lean in the state is about 2 points on margin toward Republicans over the past couple of cycles, and we're predicting a 5-point victory for Joe Biden based on our fundamentals. So our fundamentals prior at the state level would predict for Florida, absent any home state effects, of course, since none of the candidates are from Florida. Well, I guess you could perhaps make the case Donald Trump is, though we use New York as his home state like other forecasters do. But since we have both those sources of information, we would predict Florida going to Joe Biden by about 3 percentage points. And we can simulate the error from both of these models, both the national fundamentals model, which I noted has an out of sample root mean squared error close to 10 points on margin, plus the state level error, which is close to 5 points on margin additional. And we have a mean and a standard deviation for each state, and that gives us a rough idea of what should happen in each state. And we plug in those state level priors to our formal Bayesian model, which I'll talk about now, mainly in the context of polling aggregation and pooling the polls, rather than forecasting, as I think the polling aggregation model is the most important contribution, is sort of academically, and certainly the most relevant to this discussion here. So the first thing to do to orient ourselves over sort of what our polling aggregation model is doing is that it's fitting a trend line through points. Now we are modeling latent intention to vote as a function of time, and we're making that model fit to polls, which have sort of some amount of measurement error in them. But at the most basic level, right, this is very similar to running the low-s command to smooth out a trend line. Although, again, there are some important Bayesian differences with exactly what we are doing. And, it's a bit fancier than what I've described. So let's talk about what exactly we are doing. So we are modeling state level, like I said, latent vote intention for the Democratic candidate as a share of the two-party vote as a random walk over time. So we allow our estimate of Biden's share in Florida to change between now and the election. And that allows us earlier on, or especially earlier on, I should say, to pool our prediction toward state level fundamentals prior. So earlier on in the election, our time series model, as it's a random walk, would have more error in its election day prediction, and it would get shrunk more toward the fundamentals than it is, say, today, when our election day prediction is almost entirely driven by the polls, about 80% or so, and it'll be 90% or so by election day. Now, of course, that's just the forecasting part. Let's talk about the poll aggregation specifically. So on any given day of the campaign, we are modeling, say, today, which is October 19th, Joe Biden's share of the vote, let's say in North Carolina this time, based on our starting prior, and then the distribution of all the polls that we've seen so far, with, again, time series random walk. So our estimate of his support, our mean estimate of his support, and our likelihood function is allowed to change over time. And that likelihood function is updated with polls. So here we're sort of moving away from the weighted averaging concept of polling aggregation to the more sort of Bayesian idea where you have a distribution of possibilities, and you fit that distribution essentially to the polling information you have. Now, we think polls are useful observations, but are not oracular, of course. That idea should find a good audience here. So we include quite a bit of measurement error for each poll, and we also think that there are some systematic biases, and by biases I mean differences from the trend or from the average, not necessarily partisan biases, that are important to control for. So when we are fitting our state level latent vote share time series, we update it with a poll, and we allow each poll to have residual uniform bias based off of whether or not all the polls from that pollster, or so-called house effects, have ended up above the trend line for the last few months or below it. We allow another random effect for whether or not all polls of one mode seem to be biased across states toward one candidate, which doesn't actually seem to be the case right now, reassuringly. And we allow another random effect, just again, sort of standard in the polling aggregation literature for whether or not polls of likelier registered voters are over or just underestimating one candidate, again, relative to the trend line. And here there are some biases that we would expect. Polls of all adults are more favorable to Joe Biden than polls of likely voters, which I think we should expect given the non-voter population tends to lean toward Democrats. But we go one step further. Again, I guess if you were a different polling aggregator or forecaster, you might stop here. But we've tried to incorporate more information about polls than some others. So we're going to also include a correction. This could be a simple random effect if we wanted, for whether or not a pollster weights by party, or what we think to be a good control for partisan non-response. And it's not just self-identified party, but if you're weighting toward the voter file, modeled partisanship, or party registration, or the past vote if you're an internet panel, then we consider you to be correcting for partisan non-response in a way that allows our model not to react to phantom swings in the polls. And we've seen that be the case this year and in 2016, when conventions and debates caused what seemed to be large swings in unpartisan weighted data, but not in data that weighted by party or controlled for partisan non-response in another way, that bounced and faded over time back toward the average. So given that this that what we're correcting for really sort of bounces in the polls, we model our partisan non-response correction as an autoregressive process that is allowed to change, but trends back toward the average over time if it's not updated with new information, essentially allowing our polling average to skirt around events that aren't causing real movement in the polls. Though, of course, if we're seeing movement from both pollsters that don't weight by party and pollsters that do weight by party, then our model will react to that. This creates some notable differences in how our model works versus other models, and we can see some of those differences here. It's quite the mess of a plot from our GitHub repository for the model. Just look at the top line for now, where the purple dot is the result. The red dot is our modeled prediction of Clinton's vote share in the state. And the green dot is the polls. So you can see our prediction for Wisconsin was lower than a raw average of the polls would have given, and even lower than our prior prediction. And that's because when our model was trying to debias the raw average of polls in Wisconsin, not only did it find a trend line right toward Clinton over the last couple of weeks, but it also found a persistent bias in some of the data from Wisconsin that didn't weight by party. And we can see similar things across the Midwest, especially in Pennsylvania, which I've highlighted here, where again, the model, the red dot, comes in lower than both the prior and the polling aggregate. We think that that's a useful correction to make. Now, there's also a cool byproduct of the partisan non-response correction that we didn't directly consider over time, or at first, but over time we found out was doing some other useful things, and that is that the set of pollsters that we include as weighting by party or controlling for party registration or non-response in other ways also tend to weight by other important variables like education in 2016. So our model is also picking up systematic differences in the sets of what we would call the highest quality pollsters who are weighting or controlling for political composition of their surveys, as well as demographic ones, and those who weren't even controlling for demographics in the right way. So our partisan non-response corrections also picking up residual differences in pollsters that are using what we would consider to be sort of subpar weighting algorithms, in 2016 algorithms that weren't controlling for education, or especially a sort of race by education. interaction. And that leads our model to have some sort of best-in-class predictions, at least for 2016. This isn't always the case, but in 2016, when we saw large biases in the polls that both missed toward the fundamentals, and which we were able to debias a bit further by thinking about poll level information like weighting schemes. We were able to predict more states correctly. We had lower lower probabilistic miscalibration than some of the other, or I guess in this case, all of the other forecasters. So we think that this is sort of an important contribution for poll aggregation, something that's worth thinking about more. Now, there are some further considerations with the model, but for now, I guess you can consider our record here giving giving Hillary Clinton a just over 2 in 3 chance in 2016, we think is pretty good. You can see this sort of seesaw or sine wave in her support is a bit less exaggerated than it was in other models that had her losing the popular vote after Trump's convention in July, which our model sort of adjusted for, which is what we were hoping it would do. And then here's another sort of messy plot of what happens. In this election cycle, we see a large increase in July, absent some of the other swings we've seen in the campaign. Around the Republican National Convention, we picked up a 0.5 percentage point decrease nationally in Joe Biden's vote share, but none of the other large swings that we were seeing in other polling aggregate sites like 538 or Real Clear Politics. And we've seen, as you can see here, a slight uptick in Joe Biden's national vote share recently, though again, not by 4 or 5 points or even 3 or 4 points as we've seen in other websites. There are some further considerations. We think that the non-response and education correction could be separated to sort of more explicitly model the impacts of both. There's also one other large weakness in the way our model handles House effects, which is that, again, we're only modeling systematic biases from the average or from the trend line in each state. When we know that, or at least we have some prior information that we could leverage but aren't, about pollster quality. Some pollsters having worse or more biased estimates in ways that are actually biased from results or imprecise for other reasons. Our model doesn't know that information. So that's something we could work on for the next election cycle. There's also a final consideration about how the model is using fundamentals information, which is about whether or not we should have higher standard errors for smaller or larger states or states with more or less polling information, which we don't have now. So those are three areas we could improve on. I guess I've taken up 5 extra minutes of time, so I'll pass it back to Brian now. We can do some Q&A.
Great, thank you. Thank you very much, Elliott. And we've already got a ton of questions coming in, as you might have expected. So I'm just I'll read off a couple. I have some of my own that I might ask as well, but several of these are actually overlap with things I wanted to ask you about. So I'll ask, the first question I'll ask you is, how much improvement do you see in the model fit when you include the polarization interaction term? So how much additional work is that doing over the model without that?
Yeah, I'll say just first, it does seem to be significant. So it survives all of our model selection regularization procedures. So it's optimizing out of sample accuracy in a way that we would think suggests you should use the variable, at least in this parameterization. So if that's the concern, I'm not, I think I'm certainly confident that this is something we should be doing, and it improves accuracy mainly for the most recent elections. It markedly improves log likelihood and deviance measures of likelihood of outcomes in the national popular vote. And it decreases our bias by about 1/4 percentage point. And I'm talking about Democratic vote share, so about 0.5 point on margin in that case. So it's a significant difference.
Great. So we had another question, which I think is an interesting one, which is asking, how correlated does your model deem Florida and Pennsylvania? In other words, if Florida ends up being a 5-point miss, how much do you think Pennsylvania will miss by? And I think a more general thing about Florida that I think is interesting is that it seems rather inelastic compared to other states. It doesn't, the outcomes don't seem to move as much in Florida as they do in other states. And so I'm curious how Florida plays compared to other states, or if it's truly a unique state in some ways.
So this is actually, I should have mentioned four areas for more research. The way our model treats correlations between states is something we've put together essentially to predict polling error and model misses over the training set. So Florida and Pennsylvania, to directly answer the question, have a correlation of about 0.7 in our model. But if we formulated the correlations differently, if we use different variables, right now we use race and education interaction, population density, religiosity, the things you would think might predict hypothetical polling error, but it's not estimated from data in any way. So that's one way we could improve the model. Florida and Pennsylvania tend to move together in our model, I guess, based off of these correlations, but they do have different, very, very different levels of support for the president right now, about 4 points, I think, on difference in our polling average. So while we should expect the polls to miss in a correlated way, that doesn't necessarily mean that the means won't be that correlated.
Great. We have another question here who, first off, says, super interesting talk. I always want to make sure to get in the praise before the question. This individual says, on Twitter, you've noted that the 538 model has trended towards yours over time and suggested that this movement validates your model's accuracy. But is it truly possible to ever know retroactively whose model is more correct X number of days prior to the election rather than on election day itself?
Yeah, that's the problem with predicting one event, right? So I should say 538's model should trend toward ours, or exactly the same way that ours should trend toward 1 or 0 if Joe Biden's leading. So it's not the trending toward our model that validates it, right? And I guess I wouldn't even say it's statistically validating. But to the extent that 538 has had to adjust its prediction more over the past month, there's been a larger increase in Joe Biden's odds than our model indicates something sort of robust about the way we've parameterized uncertainty or the fundamentals. Whereas, Nate Silver was pricing in a lot of shrinkage and a lot of uncertainty in the race. Our prediction was essentially saying Joe Biden has a robust lead in the polls, one that we think is matched by the fundamentals. Again, that's a point of disagreement between Nate and I. And we think that because the electoral environment is polarized, and because we don't see a lot or any evidence really at all that COVID has changed the variance or the uncertainty in the election, then therefore that the race should be pretty stable. Now that gamble turned out to be correct this time, but you're picking up on a sort of fundamental weakness of calibrating probabilistic models, which is we only ever observed the election once. Now, based on what we observed this time, we should say it's probably the right adjustment to make, but there's no way to conclude for sure. So that's why I've been saying on Twitter, it's impossible to know for sure who's right, but we can probably make some informed guesses about it.
So coming back to I think that the measure of polarization and your model accounting for that is sort of a really great innovative piece that I think has also generated a lot of discussion. So naturally we have a lot of questions about that. And so one of our participants or one of our attendees asked, they just say that they don't fully understand the method of measuring polarization. How did you choose it, and why do you think it's the best way to measure polarization?
So to explain it a bit more, what we've done is we've taken the cumulative American National Election Study file, which asks people both who are you voting for, or which party are you voting for in the presidential race this year, and which party did you vote for last time. And if people tell us that they voted for a different party last time than they're voting this time, we count them as a swing voter. And if not, then we count them as a normal voter. So in 2016, that number was 5%, like just 5% of the respondents we counted as swing voters. And that's a decrease from the 1972 survey, which was 11% or so. So the prediction for 2020 is just the lagged, essentially, prediction from 2016. We use an ARMA model, but it turns out to basically just be the lagged prediction. And that's how we've parameterized polarization. It's a different measure than the sort of ideological partisan polarization you would get if you quantified roll call votes or co-sponsorship, I guess, some other measurement of how party actors vote. We're really interested in how voters, how people are voting, real behavioral changes in the electorate, because we're trying to model differences in the relationship between fundamentals and the vote. So sort of theoretically, we would think that the measure of the electorate specific polarization is better. And it turns out that there's the sort of relationship we might expect. There's a very steady measure of polarization up until the 1990s or so, and then a decrease in swing voting sort of after the rise, I guess, of mass media and polarizing figures in Congress, something that has increased mainly since the 90s and continues to increase. And I guess we could have explored more measures of polarization. I'd be curious to hear other proposals, but this one certainly seems to be robust enough for these purposes. Again, not perfect, but it makes good predictions.
Great. So we had another question. Given that we are the New England chapter of APOR, what is your model suggesting for New Hampshire, our only swing state? He says proudly. And maybe you could also just say a little, maybe I could ask you to expand a little bit and think, is there anything about the fact that New Hampshire is sort of this island of a swing state in a region that is not really, that kind of looks different? Does it make it harder for your model in any way?
So our model doesn't think New Hampshire's that swingy this year, but again, it's conditional on a national environment that's 9 points or so favored to Joe Biden. So we shouldn't really expect it to be competitive right now. I think the latter question is really interesting. So our model doesn't correlate states based on the regions that they're in, but based off of the demographic and political profiles of each state. So New Hampshire's a really good example because it has some demographic relationship to the surrounding states, Maine and Vermont mainly. I guess you can make a case for Massachusetts if someone wanted to argue that, they could. But it has a strong political relationship, or you might even say it belongs in I don't know, like a transcontinental political region with other swing states. And so since we've included political measures of the state, like its past voting history, sort of its urbanicity, it's also pretty highly correlated with the Midwest. And I guess to some extent, other swing states like Florida and North Carolina, which have been swinging at the same time that New Hampshire has been swinging. We've also tried other models that uses not correlated state errors, but just regional, national, and state-specific errors, and they do pretty well too. I guess depending on how much national error you factor into it. So, but again, the correlation is something that our models also. I should have said this up top, but our model is completely open source, so you can download it and play with the correlations if you want to. And then there's also a map on the bottom of our website that shows which states are most correlated with others per our forecast, and so you can play around with that.
Great. So I have another interesting question about the model, which I think is an interesting one to think about. Do you think that, to a large extent, presidential approval equates very closely to candidate preference, with the result that including presidential approval in your model double counts poll results?
No, so I think if we were using presidential approval as like observations of the vote that we get throughout the election cycle. In other words, if we had like 500 extra polls for presidential approval, I would be sort of worried about double counting. But because we're using it as information for our prior to calibrate economic expectations, I think I think I think they both need to be. I think the counting there is fine. I guess the best test for this is just the out of sample accuracy of our model increases a lot when we use presidential approval versus when we don't. I don't fully buy the argument that we're like sort of selecting or conditioning on our dependent variable here, measuring it directly. At least in the historical sense, there have been some notable differences between net presidential approval and net presidential vote, of course, especially in open election years. So while we're in this sort of hyper-polarized time where presidential approval and presidential vote are very correlated, that's not necessarily true historically. So since we have a historical model, it's useful to use both of them. And then I'll say just finally, our goal is both to explain politics using our sort of fundamental like causal inferencing type model, but also to predict things. So, at the end of the day, if including presidential approval helps us predict the election, that's I think a pretty good reason for us to use it.
Yeah, sure. Great. So speaking of sort of what the goal is, I'm sure you always get this question. So I'm sure you're ready for it. But are you concerned that the public may misinterpret a large probability of a candidate winning as a near certainty, and that some voters might not vote, thinking the election is basically decided for or against their candidate?
Yeah, we're certainly worried about the behavioral consequences of forecasting. Now, I think the case that people modify their turnout is a bit overstated. I think the literature is actually pretty thin here. It's certainly something that we've been happy to share information with researchers doing work on this, or even to sort of defend the studies publicly, because we think someone needs to do them, or to the extent that we can be a part of them or not, we think they're worthwhile. So I'm not necessarily worried about like 20 percentage point differences in turnout, or even like 5 or 6. But even to the extent that our model causes one person not to vote, we're concerned about that. Our goal is to, like I said, explain politics, explain how people are making their decisions, explaining behavior, and to predict things. So if like something else is nefarious is seeping in there, it's undesirable. Now, again, I don't think it's as huge a concern as some people seem to think, just based off of the empirical studies we have. The effects are either small or not like extremely externally valid. But I certainly defend like the goal of the research is important.
Great. So we have a lot of kind of questions thinking more about the polling that's going into the model, and since you are a consumer of polls for sure, and someone who's a critical consumer and someone who's writing a book on polling, I guess it's useful to get your insight on all these. So one person asks, for example, did you include non-probability survey results in your non-probability polls in your model? And I think I already know the answer to this, but a follow-up question would be, what are the criteria for including a poll in your model?
Yeah, that's a really good question. Our criteria are stricter than some of the other aggregators, or it's stricter than 538, I should just say, but not so strict as to be, well, it's not so strict as to be over restrictive. So we include non-probability surveys from online panels or otherwise. Our model has an adjustment for non-probability surveys, so to the extent they're creating systematic biases, our model picks up on that, at least in the presidential vote. We only include pollsters who have a past history of sort of fudging the numbers, straight up faking data, including biased questionnaire designs, or are using data from sources we don't trust. So we don't include pollsters who use any MTurk data. We don't think it's representative, just again based off of empirical studies of the types of people who take MTurk. We think it's a pretty good decision just not to use it, especially in a data-rich environment like 2020, or maybe like data middle class environment. On questionnaire design, we omit Rasmussen and Harris X, which seemed to produce some like biased questions. So again, MTurk, we don't use Emerson or another small outlet. And then there are some pollsters that we include that we're suspect about, but we don't have like concrete proof that they're doing anything wrong, or they're doing post-processing that they've announced transparently, like we think it's wrong, but we don't want to be over restrictive in a way that's sort of damaging for the polling industry. So we're going to use their information in our models regardless. And so I'm talking mainly about Trafalgar here, which has the highest polling bias in our entire model, but who has told us sort of like what they're doing, uses a standard methodology, uses data, and from our sense has a bias that we can quantify with the controls of the model already, basically.
Great. So perhaps related to post-processing or maybe something else. Despite the reported margin of error, polls consistently do not vary as much as you might expect. For example, with a state poll margin of error of 3.5, my understanding is that the poll result could flip by as much as 7. But we don't see any pollster moving that much upon repeated polls, right? Like basically the results we get from pollsters tend to be clustered much more narrowly than the margin of errors might lead us to expect. And the question is sort of what is accounting for that? And is the true margin of error lower for some reason than what is actually reported?
So the predictive margin of error of polls historically is twice as high. Like that's the right number to use if you're thinking about this measurement error as a difference from the true election outcome. So our model includes measurement error on top, non-sampling error basically on top of the error that you can count just on how many respondents you have, and it's calibrated. It's like a percentage point and a half or so that your typical sample of 1,000 people, which would have a traditional margin of error of 3%, has something closer to 6 or 7%. There's research by Gelman and Rothschild and I think Sherrod Joel about this. So we think it's a pretty good decision to make. I guess that doesn't explain the lower variance in election outcomes, which we think are in observations from polls, which I think is a separate issue than the predictive margin of error. I guess to the extent that one pollster is making consistent weighting decisions to continually bring their estimates in line with their benchmarks, that could explain a lot of it. We might consider, in fact, thinking about that, we might have to consider that polls have their own like clustered standard errors, like at the poll level, which could be interesting.
Yeah, I was going to follow up and say, or suggest perhaps, or even ask, if there is some herding, and not necessarily in the nefarious sense, but just sort of, there might be some process by which weighting, especially weighting on past presidential vote, would just reduce the variance in general. But also, if pollsters are paying some attention to what your polling average is, or the 538's polling average is, and sort of making sure that their result is relatively coming in line with that. Let's say that some herding is happening. Would that cause problems for your model in terms of making it more certain about the state of the race than maybe it actually should be? Yeah,
definitely. If our model is getting a bunch of biased data that we haven't accounted for, it'll be biased in unpredictable ways. Now, we haven't seen a whole lot of evidence of herding this election cycle. We know that Some pollsters have done it in the past in ways that you can sort of analyze empirically based off of having both having variances that are lower than we'd expect and trending toward the trend line, moving toward the trend line. And I would be concerned about that causing biases that we couldn't control for. If it's happening only from one pollster, it's not that big of a deal because our model again has sort of generous measurement error and partisan various random effects from the trend line. So that wouldn't be worrying if it's just one pollster, even if they're prolific. But if it's multiple pollsters that are hurting from a variety of methods and populations, and maybe even with a variety of house effects, then that could be concerning.
Okay, great. So another question to think about, sort of what might happen. This I'm thinking. I kind of like you to just reflect and think about, all right, let's say it's election, the day after the election or several days after the election, however long it takes to count the votes. And we find out that basically the result was again 2 points off from the national polling average. Can you give me an argument for why that would happen in either direction? So why we might find out after the election that actually we were underestimating Biden's support by a couple of points, or that we were underestimating Trump's support by a couple of points. I'm curious sort of what would be the potential explanation that either of those might be happening.
Yeah, I can talk myself into a few different explanations. I guess several of which point to polls, several of which I think I could talk myself into better. And in those cases, it seems like Biden would have an upside. So first is that the level of support in our model is based off of state level polls. And we only use national polls to sort of fill in the gaps in trends if there aren't state level polls. So if the level of the state level polls is sort of systematically off, then I guess we should expect it to more likely miss toward the national polls, which in this case seem to be about 2 points on margin better for Joe Biden. So that's one explanation. Maybe it's because state level polls overcorrected, so to speak, for their 2016 misses. Maybe they have too high a share of non-college whites. It doesn't seem particularly likely to me, but that's one possibility. Then another possibility is non-response, at least in other models, could be inflating support for Joe Biden by election day, either because like a massive news story a week before the election causes Trump supporters not to answer live caller phones, or because of the president has repeatedly told his supporters don't trust pollsters, don't talk to them. Now we don't have any. Again, there's no systematic evidence of either of these things, but both seem possible.
Great. So another kind of another model related question, then I have one final question that I want to ask that I think you'll have an interesting answer to. In terms of the model related question, I'm kind of just curious about the role of time in the model. So especially in terms of reducing uncertainty. So I mean, in a way, we're kind of like observing this in real time because we see like poll results that aren't changing that much. And then we can see like how much more confident you become in a Biden victory over time. But how much, like what is each additional day or each additional week worth in terms of increased certainty of the outcome, essentially?
So the variance of our random walk, I guess the standard deviation of our random walk, is a square root function of time. So there's a very quick increase as you go from 0 to 10 or 20 days. And then it's relatively steady thereafter. So we're getting up to the point to where an additional day will decrease the standard deviation by, I guess maybe a 1/10%. But for most of the election cycle, it had a negligible effect. So we think, just to give you some raw numbers, that 300 days before the election, we should allow the polls in any given state to move with a margin of error, essentially by election day, of like 25 points on vote margin. And here at the end of, or nearly the end of the election, it'll change a lot over the next 2 weeks, right? But that margin of error is closer to like 9 points now. So it's about cut in half over the past 200 days, and then the next reduction will come over the next 20 or so.
So basically, I think right now you're saying Biden has like a 90% chance, but if the polls are unchanged in a week and a half, that's probably going to be...
That'd probably be outside the margin of error. Yeah, 95 or 96, I would think.
Yeah. Great. So one last question, which I think a lot of what I like about your work, or this intersects with a lot of what I like about the work that you do. One of our attendees asks, can you talk about data visualization and how you work towards communicating complex statistical models and outputs to readers without background in math or statistics?
Yeah, we have two, or I guess I should say 3 members of the Economist's team of visualizers working on that. So they help us a lot, or they help me and sort of the other like data-minded journalists a lot in making sure that our graphs and displays are easily understood by our audience. And they've also been a good sounding board for some of the new visualizations that we've tried to use. So we have this one chart that's just like a grid of squares, of 100 squares, and 90 of them are blue and 10 of them are red. Sort of Waffle Plot, I think is what they're called. And like a forecaster hasn't tried that before. We think it's easier for people to understand like a 90 to 10 break if you're looking at the ratio of red to blue in a plot than if you're just looking at the numbers and sort of rounding them. And that plot just came about from sort of noticing the errors in 2016 from overconfidence, and talking about some ways we might be able to better explain it. So I guess the answer is just that there's a lot of back and forth with how to best do this, and I guess there are only really guidelines. There's no one answer, which is sort of what makes this a bit tricky.
Yeah, and that's a great example of I think of a way of presenting the information so that hopefully going back to the question earlier, the effects of the model on potentially demobilizing people would not be as strong, because as you say, when people see visually a 10% chance, I think they tend to view that as more probable than when they're just given the number, essentially. So I think there's been research showing that. So it's great that you've incorporated that into the model. But our hour is up already. Fortunately, we have been able to get through a ton of great questions, and I really appreciate you taking the time. And of course, if for some reason your question was not answered here, Elliott is extremely responsive on Twitter. I don't mean to make any promises for you, but
responsive.
Yeah, too responsive. I don't know when he sleeps, or if he sleeps, I should say. But I just want to finish by thanking you very much for attending today. We had about 100 attendees here, and I think we all learned quite a bit. And I wanted to especially say that I appreciate you not just being open in terms of appearing with us and answering our questions, but also just having an open model that, like you said earlier, that people can really look at if they want to and do the work of sort of, critiquing. It's hard to open up your model to critique because people might want to critique it, but it's important and useful for science that you do that. So I really appreciate that as well.
Yeah. So if anyone in the audience is super curious about tinkering with stuff or how it works, it's all on GitHub, and you can find the links on the website. It's super easy to get to.
Great. So thank you very much, and I appreciate you being here, and thanks everyone for attending. And so that's it. Thank you very much, and
Sure.
just a few more weeks left.
And then I can sleep. All right, bye.
Yes, bye.